Welcome to Rust Basics. In this particular video, what we are going to look at is some of the basic concepts in Rust, which are variables and mutability, variable bindings, data types, functions, control flow, and modules. I'm not going to go over the definitions of this, but I'm going to jump straight into these, how to code them. So I'm going to open my Rust project. So I have it open here from our last video. I'm going to make sure that it runs. We'll go and say cargo run, and it prints hello Vivina run based on what we have here. Now let's go with the first one. First one I want to cover is variables and its mutability. So in Rust, variables are immutable by default. That means once a value is bound to a name, you cannot change that value. You can use the let keyword to define the immutable bindings. To make a variable mutable, you use the mut keyword or the mute keyword. Let's look at how that mute keyword is used. But first, let's create a variable. I'm going to say x equal to 5. Now this x is immutable variable binding. X has unchangeable value of 5, so you can't actually change it. Next, let's see how let. I'm gonna say, so if I say similar thing to y equal to 10, now this is immutable, but if I want to make it mutable, I just say mut in front of it, and that will make it mutable. Mutable variable y starts as, value 10, but can be changed. So I can go ahead and say y equal to 15 in the next line. So the value of y now is 15. I can print ln and I say x is this and y is this, x comma y, and then I just go ahead and run the function, and you will see that it says x is 5, y is 15. The value of y exchange, of course, is going to give you some warning messages here, unnecessary trailing semicolon. So it looks like I have two of them. Okay, let me get rid of it. Sometimes you do it too much. Y is, maybe it's overwritten before being read. So if you see y, I'm assigning a value and I'm saying why are you changing it in the next line. So it's just giving you some warnings, but that's fine. That's how variable and mutability works. Now next thing that we want to look at is variables bindings. Now in Rust distinguishes between copy bindings and move bindings. Simple values like integers are copied. So when you assign x equal to something and you assign y to x, what it does is it just does a copy of that and does copy binding. Whereas complex resources like strings are moved between bindings. So what happens is, let me give you an example. Let x equal to 10. I'm gonna remove this or else it will cause problem because of the same variable names. So I'm going to say x equal to 10. When I say let y equal to x, what it does, it keeps both x and y, but it just makes a copy of y's value into x. But if you use something like a string, this is how you define a string, and we'll look at more on these later. I am saying s is string which has value rust. That's what I'm saying here. Now when I say let t equal to s, what happens in this case is this is a move binding, where so s is invalid now. So s doesn't have value. It moved the value of string from rust from s to t. So that's what variable bindings are. Next, let's look at data types. Now Rust is static. I always mess that up. Rust is statically typed language, which means that it must know the types of the variables at compile time. The compiler can usually infer what type we want to use based on the value and how we use it, like how we saw in x and y. We didn't specify exactly what it is, whereas for the string here we specified that it's of type string, but Rust can actually make that evaluation by itself. Now the Rust primary types are divided into, let me just make sure I type it here. So data types, there's two different types. One is scalar types and the other one is compound types. Now what are these? Let me type this out. So once in scalar types we have integer types like signed integers, which is I32, unsigned 32 integers. We have I64, which is 64 signed integer, whereas unsigned 64 integer also there. So these are some of the types. The I32 type is generally the default because it is fast on many CPUs. There's floating points also. Let's look at some examples of. So if I say let x, if I want to specifically say what it is, I specify here like this 42. So this is a signed 32-bit integer, which is also a default value. Then we have floating point. Floating points are F32 and F64. The default type is F64 because it's roughly the same speed as F32, but it's capable of more precision. So if I want to do that, I say let y of the type F64 equal to 3.14. This is a float value here. I can, and also there is Boolean values where I can say let x equal to true or false. So these are, oh, sorry, I think I should have used some. X is true or false. So these are the Boolean values, and then we have characters. Characters are char. It represents a Unicode scalar value. So the way you define that is let c equal to char. Similarly here you can do bool, and for character you can specify c or just any character here. You can specify this is a Unicode character. So these are the scalar types that are available, which are integers, floating point, booleans, and characters. Now compound types, if you want to look at compound types, we have two different types. One is tuples and the other one is arrays. Now tuple is a general way of grouping together a number of values with a variety of types into one compound type. Let's see what I'm talking about. So if I create let t, now this tuple which has multiple values, I can say it has I32, it can have F64, it has a character. You can also put float if you want, but I'm just going to put these three. Now integers, next is float, so I'm going to 6.2 something, and then I'll give a character here. I'll say X. So this is a tuple. Another example of a tuple, let me just give me one more. If you're looking at tuples first time, this will probably help you more. I32, I'm going to say F64, and I'll have another unsigned integer, say U8. Now this is equal to, I say 500, 6.3 comma 1, something like that. Now if you want to destructure a particular tuple, like how do you use them, we also use destructuring, where I can say that the first value I want to assign it to y variable. I can do y, x, y, and z, and then I can say tuple goes into x, y, z. So what happens is the value of, let's print it, I can just say println, and I can say the value of y is, now you probably guessed it, but let's see what does the compiler say. If I run this, oh, I think I messed it up. Okay, let's run again. Two previous errors. Add colon here, so I'm missing semicolon here. Could not compile due to one previous error, which is unexpected. Let a boolean equal, okay, I forgot one here. Building, now if you see the value of y is 6.3 right here, so it takes the value. So if x value is 500, y is 6.3, and z is 1. So that's what tuples and tuples look like. Now let's go over arrays. Now arrays, unlike a tuple, every element of an array must have the same type. Arrays in Rust have a fixed length when you define it, so you have to be careful what you set. I'm going to say let a, it's an array of I32. It has all unsigned integers, and how many do I have? I have a length of 5, so I can give 1 comma 2 comma 3 comma 4 comma 5. So now this is an array of length 5, which has all signed integer 32. So I can also assign values. I can say first equal to, the way you access arrays is If you have done other programming language, it's much similar. At index 0, 0, 1, 2, 3, 4, these are the indexes for this array. I can say let second equal to say a of 1. Now if I print it, I can say the second element is colon, and inside that I can say comma and give second, run it, and it will run. And the second element is 2. So that's how it works. Don't get fooled by the indexes. Indexes start from 0, and that's why it's this is the first element, this is the second element, third, fourth, fifth. Now next thing that we'll look at is control flow. Now let me get rid of these things. Control flow. Now with control flow, there is if loop. So let's go over if loop. In Rust, if expressions allow you to branch your code depending on conditions. And if expression can optionally be followed by an else block or a chain of else if conditions. Let's look at some examples. So let's say if I say let number equal to 7, so I'm assigning a value of 7, and I am checking using if number mod 2. So what is mod? If you have never used mod before, it gives you the remainder. So 7 divided by 2 is 3, and then there's one remainder, so that's the value you get. 1 is what you get for if when you run this. Now is it equal to 0? So that's what we can check. So if it's 0, which means if anything is divisible by 2, that means its number is even. Else I can say number is odd. So in this case, what do you think? 7 is even or odd? Just by looking at it, you can probably tell that 7 is odd. And similarly, if I give 6, it will say number is even. So it divides by 2, and if the remainder is 1, which means it's not an even number, odd number, it's not an even number if it's anything other than 0. If it's 0, then it's an even number. So let's look at an else if example. I'm going to say, let's remove this. I can say if number, sorry, don't need brackets. If number mod 4, in this case, I'm going to use something different, 4 equal to 0, then I'm going to say print ln, and inside that I'm going to say number is divisible by 4 if it gives 0, because that means it's divisible by 4. Else if I'm going to give else if and give one more condition, number mod 3 equal to 0. In this case, I'm going to say println is divisible by 3. I think I misspelled. Else I'm going to use the same thing, copy this, paste it here, and say divisible by 2, divisible by 2. If none of these work, I can also give another one. If none of them work, I can say is not divisible by 4, 3, or 2. Is not divisible by any of these numbers. So in this case, if the number is 6, you know it's not divisible by 4 because it's going to give you 2 as the output of this. Number is divided by 3 is 3 times 2 is 6. So it will give you 0 and it will run this. It will not go to the next one because as soon as it meets the condition, it will go there. So if I run this particular example, you'll see it's a number is divisible by 3. Let's clear it. Now if I give a number 2 and run it, it will say divisible by 2 because 2 divided by 4 is half, so that's not possible. 3, same thing. 2 divided by 2 is 0, so that will work. Similarly, if I give 8, in this case, it will say divisible by 4. It will not go further. If I give something like 1, which is not divisible by anyone, it will say it's not divisible by 4, 3, or 2. I can give another example. Let's say let x is equal to, let's pick a random number, 42. Now if x is less than 10, I'm going to say, easier to copy, println, I'm going to say the number is small. Next I'll say else if x is less than 100, then I'm gonna say print ln number is medium, and else if it doesn't work for any of them, I can say print ln number is large. There you go. These are my conditions. For the first case, if you look, it will say medium because number is not less than 10. If I say 8 here, you'll see it says small. If the number is 120, which is bigger than 100, so it will go and run and say it's this large number. So that's how these if else conditions work. Now let's look at the next one, which is loops. So Rust provides three kinds of loops to repeat code. I'm going to just, instead of control flow, I'll call it loops. Three different types. One is loop, another one is while, and then there is for. So loop, while, and for. So the difference between the three is uh, these three constructs can handle like repetitive tasks with much ease instead of doing conditional like if else. For loop, the loop keyword tells Rust to execute a block of code over and over again forever until you explicitly tell it to stop. So if you want to run something constantly, this is the way to go. For example, I'm going to create a mutated count and I'm going to assign it a value of 0. Since I want to loop it and change the value of count, that's why I set it as mutable variable. Now this is how you set up loop. You just say loop, and inside that whatever you add, it will constantly run. And I'm going to say count increment by 1. So currently the value is 0, so it increments by 1, so the value of count will be 1 at the first go around. So let's print that out and then just see if I'm not making that out. So if I keep this like this, it will constantly run and keep on printing 1, 2, 3, 4, 5, 6, 7, 8 for infinity. So I want it to not go forever. Let's stop it after, let's say, 5. If count equal to 5, what I want to do is I want to break. So this is how you can break out of a loop. So let's run it and check if it works. So say count equal to 1, then it goes back again, increments by 1, 2, 3, 4, 5. So that's how loops work. Next, let's look at the while. The while loop is similar to loop, but it includes a condition. The loop runs as long as the condition evaluates to true. So let's keep that. Or actually, let's remove that. So I'm going to say let mutable number equal to 3, not double, single equal to 3. And then I'll say while. So the way you write while is you give the condition number is not equal to 0. So say the value of number is 3 right now. So it will run the while loop. I'm going to say print ln count my display my number. So this will display my number, and then I want to reduce by 1. So it will go from 3, it will print 3 and then reduce to 2, go again 1, and then when it becomes 0 it will not execute anymore. So let's see, just to make sure that we come outside this, I can just say print ln and say we are out of loop, or let's say while, just so we don't confuse ourselves. So let's run it. This is 3, 2, and 1, and print that out. And then when it's 0, it just gets out of the loop because they will say while number is equal to 0, this doesn't execute, so we should get out, and we are out of it. So that's how you create while loops. Next, for loops. Now the for loop is used to iterate over elements of collections such as an array or a vector. We have not seen vectors, but we'll look at it in future. But we've seen arrays. So for loop is used to iterate over that. It's the most commonly used loop for iterating over a collection because it's safe and concise. So let's look at an example to understand how for loops work. So let's create an array first. Create an array. Not gonna assign it any types because it will automatically know that I'm using an unsigned or integers with inside here based on the numbers that I've said. And now I'm going to say for element in a dot, I'm going to say iterate through it. So there's a function called as iter. So it goes over each and every number at one time. So what it does is it goes to the first element 10 and assigns it to element. And so the element's value is 10 now. And here I can say println, and I'll say the value is, give the value is the element. So you can see what I'm talking about. It keeps on going inside there, and first it will assign the value 10. Next time when it comes, it will assign the value 20, 30, 40, 50. So let's run this and see. The value is 10, that's fine, but the value is 10, 20, 30, 40, 50. So there you go. That's how for loops work. Now, if you can also use for loops with range, which is particularly useful for running a loop a certain number of times. So if you want to run a loop for a certain number of times, for example, I can say for I in 0 dot dot 5. So this means 0 to 5, not doesn't include 5. So 0, 1, 2, 3, 4. I can say the print of value is, keep the same code and run. So it's a value of 0, 1, 2, 3, 4. If you want to include 5 also, you can give 5 there. So what that does is 0, 1, 2, 3, 4, 5. So that's how you can use by a range. You can also do another thing. For example, for number inside the bracket. Now if I want to run it in a reverse order in this range, so I can say dot rev, that is a built-in function again. So it runs from 4, 3, 2, 1, something like that. You can say, get rid of this for now, is number. I will run the code and you'll see it goes, as I said, the last number is not included unless I give equal to here, something like this. Unless it will say 3, 2, 1. I can run it again, 4, 3, 2, 1. This time I gave equal to, so that's why it's 4, 3, 2, 1. So that's how for loops work. Now conditional loops with break and continue is another thing that I want to look at. We saw the break option, but let's look at continue. You can use break to exit a loop immediately, which we saw before. And continue is used to skip the rest of the iteration and begin the next iteration. So you don't have to, with break, it completely comes out of the loop. Whereas if you use continue, it will just skip that particular iteration. So what do I mean? Let's write a function. So I'm going to say one I in 1 dot dot. I want to go from 1 to 10. So that's why I'm saying equal to. And inside here, I'm going to say if number mod, let's use mod that we learned. If it's an even number, I want to continue, which means I don't want to do anything. I want to skip this particular loop and go to the next number. So 1, it will not go inside here because 1 mod 2 is not equal to 0. So it will say println. I can say the number that comes out is odd, right? Because it doesn't run for odd numbers. So it will go here, it will say 1 is odd, go second time, this time it's second, and it will continue. So skip this and go back to for loop and go to the next number 3, 4, 5. So this is how. So in this example, continue is used to skip even numbers. So only odd numbers are printed. Let's look at this. Oh, print ln, I forgot this. So run it again. So 1 is odd, 3, 5, 7, 9. So it skipped 2, 4, 6, 8, and 10. So that's how you can use continue. So these are all the things that I wanted to do about loops. So next, let's look at pattern matching with match. Pattern matching with match. Now this is a new thing. Pattern matching in Rust is a powerful feature that allows you to compare a value against a series of patterns and execute code based on which pattern matches. Now the match construct in Rust version is similar to switch statement if you use switch statement from any other languages, but is significantly powerful due to its deep integration with Rust pattern matching features. So let's look at the basic match syntax. The match expression takes a value and branches execution based on its value, allowing one of the several code patterns to be executed. So for example, let's say I create a let coin equal to, we're gonna look over enums later, but let's say coin is an enum representing different types of coins that matches expression. So what I'm gonna do is I'm gonna say coin has penny. So this value of coin is a coin penny. Now let's create the enum name coin, and I'm gonna say there's different types of coins. One is penny type, the other type is nickel, next type is dime, and the last type is quarter. Now these are all American coins. Penny is a cent, nickel is 5 cents, dime is 10 cents, and quarter is 25 cents. So I'm creating a coin object and I'm saying coin is of type penny. Now the way you use match is you first say match and then match the coin value to what is it? Is it coin of the type penny? If it is, use the arrow and say print ln, and we say lucky penny. Let's say that what we say. Next we give comma. If it doesn't match, like switch statement, I'm going to use for all four of them. And the let's say if it's nickel, what to do? If it's dime, what to do? Quarter, what to do? Let's see, what should we write for nickel? Say it's a nickel. I can't come up with anything crazy. I'll say dime detected, and for quarter I'm gonna say quarter of a dollar. Okay, now this is how it will print out based on what it matches. Let's run this and see how this works. So if you see here, it says lucky penny. Hello Vivinarana and lucky penny. So it matched coin to penny because the value is penny, and it's going to print out that particular value. Now if I change it to dime, it's a dime detected based on which statement. So you can kind of run a function or do whatever you want in here based on. We'll cover some more advanced match in future videos, but this will give you a basic idea of how match works. Next I want to look at is functions. What I'm going to do first is functions. Now fn is what you use. Functions are declared using that fn keyword. Rust code uses like snake case as conventional style for functions and variable names. So what I'm going to do is I'm going to create another function outside. What should I call it? I'll call it another function. Very intuitive. And then I can give two parameters. So this function takes two parameters. So I can say first parameter is I of the type signed 32 integer, and second one is y, which is of the type float 64. This function takes two values. I can say print ln exclamation the value of x is whatever value is passed from, let's say, main function. I'm going to print it here. Same thing for y. I'm going to do the same thing. I'll say to make it look pretty, I'm going to do it this way. And now to call this function, what you do is you just call the name and pass it values. The first one is integer, the second one is float, so I'm going to give 6.3, something like that. And then I run this and you'll see it says value of x is 5, so it passes the value to this and print it out. When you call this function, you need to provide the arguments in the same order as the parameter. So you can't say 6.3 and 5. You give it in the same particular order for functions. So we'll look at more functions as and when we use it. But for now, this is good. Next thing that I'm going to show is modules. Now modules is if your code is becoming too messy and everything, you're till now we only used one file. So what if I want to create another file and write something inside that? For example, I want to create a function inside here. I'm assigning pub, which means public function, which is available to outside. I'm giving it two parameters, x I 32, so both integers, and it returns back this, which is, so what it does is it will take the value of the operation inside and return back that value. So it takes two integers and returns back an integer. So I'm going to save this as, let's say, math.rs, And then I'm going to go back here. First of all, if you want to add that module into this particular function, I'm going to go up there and I'm going to say I want to use that module called as math module. So what it does is this brings mat.rs code into the scope of this. Now in here, I'm going to say modules, and inside here I can say, for example, print ln. Now I can say sum is, since that is an add operation over there, I'm going to say use the math module, and then inside that there is a public function add, and I want to pass 3 and 4 to it. So that's how you can incorporate a module inside your main function. Let's go run it and you'll see math. So what it does is, you don't need all these things. I'm going to get rid of this. So what it does is it will take it will go inside here and it will say sum is the value of whatever is returned back from here. Now if you see, the return back is an integer, but it wants two integers, so that's why I'm passing 3 and 4 here. It will add those two numbers and return back 3 plus 4 7 to me. So that kind of covers our entire section of doing variables, variable mutability, variable bindings, data types, functions, control flow, and modules. So if you have any questions on this, hit me up with comments down there, and we'll cover more sections in future. Thank you.